Okay, in this video we're going to be doing Calc AB Problem Set 21. There's a link to the problems and a playlist of all the problem sets down below in the description, and let's get started. Number 1, find the second derivative for y equals the natural log of x cubed. Alright, so when I find derivatives of natural logs, what I tend to do is I tend to just start off with the derivative of the thing, but I mean it's 1 over the thing times the derivative of the thing, so times 3x squared. I'm going to simplify this because I'm going to find the second derivative. I would simplify that anyway. So you can also think of the natural log of x cubed as 3 natural log of x. That's one of the properties of logs that you should definitely know, that exponents become coefficients. If that's the case, it's a lot easier to find the derivative, I think, because you're just finding the derivative natural log and then multiplying by 3. Either way, you end up at 3 over x. It is better probably to find the second derivative, to think of this as 3 times x to the negative first. And then we want to find the second derivative, so we're just going to use the power rule. So the second derivative, bring the exponent down, subtract 1, we get that. You could leave that, or you could rewrite it as negative 3 over x squared. Next problem. We want to evaluate the limit as x approaches 5. So as soon as I see this, I think this is almost certainly the derivative, because I don't really know how I'm doing a limit that involves secant otherwise. So it's the limit as x approaches 5, secant of pi over 3x minus secant of 5 pi over 3, all over x minus 5. So if you look at it, you can definitely see that the function is secant of pi over 3. We're evaluating the derivative of this function at x equals 5. We know it's x equals 5 because we're finding the limit as x approaches 5. So I just need to find the derivative. So the derivative of secant of something is going to be secant tan times the derivative of that thing. So the derivative is pi over 3, then we got secant of the thing, tan of the thing. Memorize your trig derivatives. They're going to serve you really well throughout all of calculus, including when you learn to reverse taking derivatives, to find antiderivatives. All right, now we need to plug in 5. I'm not going to make you watch that. And we need to evaluate it. So we get pi over 3. The cosine of 5 pi over 3 is 1/2, so the secant is 2, and then the tangent of pi over 3 is root 3, 5 pi over 3 is in the fourth quadrant, so you get negative root 3. So finally our answer is negative 2 root 3 pi all over 3. All right, good problem, I guess. Solve the derivative of cosine of 3x is greater than 0 for x between 0 and pi. So this is a pretty common type of problem. I wouldn't say this would be the question. The question would more be something moves with position cosine of 3x, when is the thing moving to the right or something like that. But either way, I mean, that's what the problem boils down to. So let's find this derivative. So the derivative of cosine of 3x, we're just going to use the chain rule. And remember, the derivative of cosine is negative sine. So we get negative sine of 3x times 3, or negative 3 sine of 3x. We need to solve this thing. What I'm going to choose to do here is set up a graph and just do this graphically. I know how to graph negative sine of 3x, so I'm going to use that to my advantage. So the period is 2 pi divided by 3, so then we divide that by 4 to get our increment. We plot this all. I have a bunch of videos on graphing trig functions. Highly recommend you know how to graph simple trig transformations. So change the period, move it up and down. I don't think you need to shift it left and right. You don't see that a lot in calculus. I mean, you should know it, but you don't see it a lot. So we're looking for greater than 0. So that's going to be between pi over 3 and 2 pi over 3. So that's going to be our answer. And pretty good question. I mean, shows the technique of graphing. All right, find the average rate of change, algebra 1 slope, of f of x equals the quantity x plus 2 squared all over x minus 1 from 2 to 3. So this is literally just algebra 1 slope. So sure. I'm going to set it up like this, f of 3 minus f of 2 over 3 minus 2. And then I'm just going to plug in. So when we plug in 3, we get 25 over 2. When we plug in 2, we get 16 over 1. And then 3 minus 2 is 1. And then this will be 25 minus 32 all over 2. So negative 7 over 2. And that's the problem set. So I hope you found this helpful, and good luck.